Imagine a power plant so large that it never touches the Earth. It circles our planet silently while collecting sunlight almost every second of the year. No clouds block it. No storms interrupt it. No night ever truly shuts it down. This is the vision of space-based solar power. For decades, the idea sounded like science fiction. Today, it is being studied by real engineers with real hardware. The goal is simple: collect energy in space, send it to Earth wirelessly, and potentially change the future of electricity forever. The story begins long before reusable rockets existed. Scientists noticed a simple fact about space. Above the atmosphere, sunlight is stronger and more consistent. In 1968, a pioneering concept proposed giant solar satellites. The design looked enormous even by modern standards. Yet, the physics behind it was surprisingly sound. The real problem was cost. Launching thousands of tons into orbit was almost unimaginable. So the idea remained mostly theoretical. But technology kept advancing. Solar panels became lighter. Rockets became dramatically cheaper. The operating principle is elegant. Massive solar arrays capture sunlight in orbit. The panels convert light into electricity. That electricity powers microwave transmitters. The energy is then focused into a controlled beam. Ground stations receive the signal using giant rectennas. Those systems convert the beam back into electricity. The electricity then enters the power grid. At first, the concept sounds almost magical. Yet, wireless power transmission has been demonstrated for years. The challenge is scaling it to extraordinary dimensions. And that is where the real engineering battle begins. Building one satellite may require thousands of components. Some concepts stretch for kilometers. No existing rocket can launch such a structure in one piece. Engineers therefore imagine orbital construction sites. Robots could assemble modules autonomously. Artificial intelligence may coordinate the process. Every kilogram saved reduces launch costs. Every failure in orbit becomes expensive. Reliability becomes a matter of economics. Durability becomes a matter of survival. Micrometeoroids and radiation never stop testing the hardware. The power station must keep working for decades. Around the world, governments have taken notice. Multiple countries are studying orbital solar power programs. Universities are testing transmission technologies. Private companies see a potential trillion-dollar opportunity. Reusable launch systems have changed the equation. Lower launch costs make old ideas look new again. Demonstration missions are already proving key concepts. Small successes are slowly building confidence. Yet, nobody has built a full-scale system. The race is still in its early chapters. The winner could reshape global energy markets and perhaps redefine the relationship between space and civilization. Every revolutionary technology faces difficult questions. Space solar power is no exception. The first concern is cost. Building orbital infrastructure could require enormous investment. Another concern involves transmission safety. Engineers must ensure the beam remains precisely controlled. Space debris introduces another layer of complexity. Large satellites create larger targets. Maintenance could become a continuous challenge. Economic competition from terrestrial renewables remains intense. Ground-based energy keeps getting cheaper. Space-based systems must prove they offer something unique. Despite the obstacles, the promise remains extraordinary. Space offers nearly continuous access to solar energy. That means electricity could be delivered day and night. Remote regions could receive power without massive fuel shipments. Disaster zones could potentially receive emergency electricity. Future industries may depend on abundant clean energy. The concept also pushes humanity toward large-scale space infrastructure. In solving an energy challenge, we may accelerate a space age. The most fascinating part is that the idea never really changed. What changed was our ability to build it. Somewhere above Earth, the future power plant may already be taking shape in an engineer's imagination. And if that future arrives, the sunlight powering your home might begin its journey hundreds of kilometers above your head.